having me back here. Pretty excited about that. I wish I was in person in Nashville. I really enjoyed it last year, and again, thank you for having me back here. So, anyways, today we're going to talk about optimizing serverless workflows. So, just quickly, a little bit about me, if I can get this working. Which apparently I can't. Here we go. So my name is Jeremy Daly. I'm now the GM of Serverless Cloud at Serverless Inc. I've been working for a bunch of other companies in the past, and I think I found a really interesting role here, and I've got some stuff to share with you about what we're working on at Serverless in the future. A couple other things. I have been consulting with companies that are building in the cloud for a very, very long time. I've been doing this, like I said, a long time. That's why I have all this nice gray in my beard here. I started working with AWS very early on, back when it was just EC2, before there were like load balancers and some of this other stuff, and then started using Lambda in 2015. So I've been doing the serverless thing for quite some time. I also blog. I do a couple of OSS projects. I obviously speak. I publish a newsletter every week that comes out on Tuesdays. Today's a Tuesday, so make sure you subscribe at offbynone.io. Just a bunch of updates of what's happening in the serverless space and all the new announcements. It's very heavily AWS focused, but I also try to cover the entire space. And then I founded, and now I'm the co-host of the Serverless Chats podcast. We just welcomed Rebecca Marshburn on as a co-host. So we have some really great conversations. So check that out as well. And also, I'm a serverless hero through AWS, which is a great program that really helps you. That we get sort of early access to information, and we get a lot of feedback that we can do. And it's just a wonderful program that really gives us a chance to give that early feedback and be part of the process as serverless and other AWS services develop. Okay, so what are we going to talk about today? Well, first of all, we're going to talk about how adopting serverless is just incredibly easy. It's all rainbows and unicorns. I think you'll all agree with this. Hopefully you heard a little bit of that sarcasm in my voice, because I think we all know that it is very difficult to create serverless applications nowadays. Not so much because of the getting started ramp, but more of the longer term things and getting to those production applications. So we're going to talk a little bit more about that. We're also going to talk about how, when we start to adopt serverless in our organizations, how that changes our workflows and shifts that responsibility and who that responsibility is shifted to. We're going to give a couple of tips for optimizing serverless developer productivity. I wish there were more here. There's a lot of tools and services out there that can help with this, and we'll talk about a few of those. But we'll give some of those tips and talk about a couple of considerations. And then finally, we're going to talk about the next sort of evolution/revolution of serverless and the cloud. There are a lot of really, really cool things happening right now that are moving towards more automation, that are moving towards more low-code solutions and things like that, that are making it easier and easier to develop serverless applications. So we're going to go through some of those, and then I'm going to share with you what we're doing at Serverless Inc. and how we're trying to, sort of lead the charge, or at least be part of this movement here of trying to make serverless easier for everyone. So let's jump right in and talk about this slide. So this is the slide that AWS shared at reInvent 2018, if anybody remembers reInvent in person. So the premise of this was that serverless was an operational construct, meaning that the more you had to manage, or the certain services in AWS, like VMs, EC2, even if you're running MySQL on EC2, things like that, those require a lot more operations. And as you start to move over this spectrum, you get to less operations. So those are things like Lambda and Fargate and DynamoDB. And that makes a lot of sense. I think a lot of people sort of buy into this idea that the more serverless you go, the less operations you have to deal with. And now that sounds good. And again, it is a good thing because we don't have to manage the underlying infrastructure. But there's something else that happens here. The more operations that are required, usually the less developer responsibility there is. That used to be the old days where we throw code over the wall, and the developer and the ops team would go ahead and launch that code for us, or set up all the servers, and we wouldn't have to worry about that. But now, as you go over to the less operation side of things, we actually now put more developer or more responsibility on the individual developers. I don't really have a term for this, but I just call this maybe the cloud know-how spectrum, right? Which essentially says that the less ops that are involved, actually, the more the developers need to understand about the infrastructure. So for people that are adopting serverless, and I don't know who created this meme, but it's wonderful. But essentially, this is this impression that there's a lot of unicorns and a lot of rainbows and a lot of sort of hype about serverless, where we say, oh, it's super easy, it does all the stuff for you, you don't have to manage the infrastructure, you don't have to manage the infrastructure, you don't have to do some of these other things. But here's that typical serverless developer experience. We start with our Hello World example app, right? A couple of lines of code, just go ahead and use serverless framework or SAM or one of these things, right? Super exciting, very, very easy to get there, immediately productive. Hey, we've got this great app, it's running, and look at this, we're serverless, we're a serverless team now. But the reality of these real world production serverless applications are much more disappointing, because there are so many things that you have to think about and so many things that you have to learn. And there's a whole new skill set that has to be learned in here, especially on the developer side. And if anybody remembers this article, I think it's maybe a year and a half ago. So Xavier Lefebvre, I can't pronounce his last name, but Xavier created this typical serverless architecture post, which was great. And this created all kinds of, people saying, well, look how hard, serverless is. And then it was defended by saying, yes, but you have so much more control over these individual components. And really what we're just doing is, we're kind of giving you visibility and control over these individual components. That's great, but you've got Event Bridge in there. You've got step functions. You've got Lambda functions. You've got DynamoDB. We've got something called Amplify in there. We've got all these different services that need to be orchestrated together or configured together so that we can actually run a full application. And that is a lot of different services we have to think about. So again, this is another meme that I thought was fun. But essentially, this is what it's like planning a serverless app. Is you're saying, I need this to do this and this to do this, and this needs to connect to this. And it's just a lot of overhead to think about. And even if you go through this whole process and you plan out this, really great serverless app, you got the infrastructure, the infrastructure template that's laid out like the typical serverless architecture, you run into this problem where serverless doesn't always work in every single situation. So in most cases, you can rethink your application and get it to work serverlessly. But other times it does make sense. Machine learning, if you're using some of these other things, and again, I hate to use that as the example, but sometimes long running workloads make sense to use a Fargate container or run those, in a containerized workload. Sometimes you have other requirements that require you to have a Kubernetes cluster running and you need to interact with that. So it's not always possible to build everything in serverless. For the most part, it is. Basically the way I see it is if you can't build it in serverless, then don't build it at all. But obviously that's not going to work for everybody. And not only is it that even if you do come up with the perfect serverless solution, one of the things that we have to deal with serverless, and certainly with AWS, is that there's 19 different ways to deploy a container on AWS. There are a ton of different ways to do, there's, or I shouldn't say ton, but there are multiple ways to do, like an API gateway or to do HTTP. There's a couple different ways that you can handle WebSockets. You can use AppSync, you can use API gateway, you can use IoT. So there's a number of different possibilities, and all of those possibilities, all of those different services have different use cases and different reasons why you might choose them. So if we were to move to something that maybe we consider to be a perfect developer, a perfect serverless developer environment, which I'm not sure this exists right now, but this would be something where we would want to make sure we're using familiar tools. We want really, really short code iteration and feedback cycles. So we want to be able to test our code very, very quickly. We also, because we're using all these managed services, we want to make sure we can iterate on those very quickly. So if we need to deploy a Kinesis stream or we need to set up another SQS queue, we want to be able to do those quickly so that as we're coding, all those changes are happening very, very quickly. And of course, we want to have parity with the production environment. If we're deploying into these test environments or running something locally that doesn't match up with how the cloud actually works, well, that becomes a problem potentially for actually putting your code into production. And one of the things that was interesting that Eric Johnson mentioned this morning is this idea of bringing the developer to the cloud as opposed to the cloud to the developer, which means, again, you're going to actually be using cloud resources to test these things as opposed to trying to run them locally or emulate them locally. So when you're taking on the serverless application and you're building out serverless applications, I remember the days where things were pretty simple. You just upload stuff to FTP and it was live, and there you go. Now, clearly those weren't distributed applications. They didn't scale very well. There are all kinds of reasons why there were problems with those. And the cloud and cloud native is a much better way for us to be deploying these applications now, so that we can deploy them to scale and have redundancy and failover and global replication and all these really cool things. But as someone who now has to take on a lot of that responsibility, sort of this new developer, this new serverless developer has to think about a number of different things. So first of all, you've got infrastructure, right? And for most developers, right? And this is the other thing. If you've been developing on the cloud for a while, this is probably something you're like, oh yeah, no, infrastructure just makes sense. But for a vast majority of developers, they never see infrastructure. They don't even know where their application runs. All they know is they have to write in .NET or Java or whatever. And there might be some parameters they have to follow, but for the most part, infrastructure is a new concept to them, at least the configuration of it. So business logic is something that is old hat to most developers. But in the cloud context and in the serverless context, it's not the same as it was before. And we'll talk a little bit more about why that is. And then build and deployment pipelines. So I think a lot of people who are deploying applications, especially in the cloud space or even in the even on-prem and things like that, are probably familiar with build tools like the Jenkins and all the CI/CD things and some of those. But there's a lot of new concepts. So even though there's some old concepts in there, there's some new concepts that we have to learn as well. And then monitoring and observability, this idea of just saying, that's ops jobs, that's not the case anymore. There's a lot of things that we have to think about when we deploy code. And we'll talk a little bit more about that. But the idea here is that now that ops team, as we move more towards DevOps, we move more towards teams that try to, manage the operations themselves. There's a lot to think about there. And finally, I don't even want to cover this subject because it's way too long. I know Trend Micro is a sponsor today, and you can talk to them more about it. But application security is a big thing to think about. And this now, a lot of that onus falls on the developer now to be thinking about which patterns they have to apply. Perimeter security is great with serverless. I think out of the box, you get much better security, but application security is still your responsibility. And there's not the same tools that there are for your more standard applications. So let's talk about infrastructure and sort of what the differences are there. So first of all, as a serverless developer, if you're going to build something serverlessly, that means using a lot of managed services. But it's not just saying, oh, I'm going to use DynamoDB and I'm going to use API Gateway and I'm going to use EventBridge. It's also about understanding the limits that are there, because there are a lot of limits in the cloud. They're generally well published, so you can go and look what those limits are. But there are a lot of limits that you sometimes have to work around. There's also a lot of nuances, right? I mentioned the idea of using AppSync versus API Gateway WebSockets versus using AWS IoT or MQTT and doing that for doing WebSockets. There are reasons why you would use one over the other. There's advantages to others and so forth. And those are things that you need to really study and understand. And there's also, 50 million lines of documentation, or it's a lot of documentation to read through. The other thing is that, again, this is a change in paradigm, right? So in the past, when we thought about infrastructure, we may have thought of, hey, I'm just going to go ahead and upload code, to this particular service, or I'm going to dump it into, into my GitHub. Or into my Git repository, and that's going to go ahead and deploy that through some CI/CD process. And in many of those cases, we're talking about monolithic builds, right, where we're just worrying about the actual code itself. But now there's a big change in paradigm, right? We're not Ruby on Rails anymore. We're not a mean stack or a lamp stack. We're not doing monolithic deployments. We often are deploying things to multiple resources or making configuration changes across multiple resources. And that's something you have to think about when building out your code and building out your applications, and how the management of that infrastructure is going to happen. And then finally, infrastructure as code. For most people, this is a completely new concept. I think back in the Ansible days, or I think Ansible is still around, so apologies if it still is, but I don't really manage too much infrastructure anymore. But maybe Chef and Puppet and those things, those just barely seem to be maturing sometime around, 2014, my timeline may be off there, but now here we are only a few years later, and already we're talking about, complete infrastructure as code, where we're really merging our application with the infrastructure and sort of combining those two things together. If we look at the business logic side of things, this is another thing that Eric talked about, is that local emulation, it's really, really hard to duplicate the cloud locally. And you've got things like local stack, and there's actually a couple of services, Architect, which I think that Eric mentioned as well, does a really, really cool job of sort of building all of that in for you and makes it very, very easy for you to test some of that stuff locally, but most other services don't have that. CDK, serverless framework, yes, you can replicate certain things. SAM, you can do SAM local, and you can get an HTTP API in there, and that's great. But then you want to actually reach out and touch, cloud services, because you want to make sure that you're not trying to run DynamoDB locally or trying to run SQS locally or something like that. Another thing is, with our business logic, we need to think about stage isolation, because oftentimes, even if we are doing some sort of monolithic deployment, if we have a monolithic service, we're still deploying to multiple stacks, or we should be deploying to multiple stacks. Sometimes you have ephemeral stacks that are maybe like your Lambda functions or your Fargate containers, or something that you can change on a regular basis that you're going to iterate on quickly. And then you have more permanent infrastructure, maybe a DynamoDB table. You don't want to be tearing that down and spinning that back up every time you do a deployment or potentially modifying it. So you might want to deploy some of those things as more sort of long-term, more permanent instances, or permanent part of a permanent stack. And so thinking about how you write your code and how you configure your code and how you do all these other things to make sure it's talking to the right resource in the right stage is, again, just something else we have to think about. And in many cases, that wasn't the problem, usually because we'd be communicating maybe with a local port or something like that. And that has all gone away as we move into these distributed systems. And then finally, I would mention this because hexagonal architecture, if you're not familiar with this, this is just something where I think this is the right way to think about building serverless applications now, and actually building any application in the cloud. And this is a way that is sort of ports and adapters. You can look this up, but it's a very handy way to deploy applications or to build applications, because it gives you the ability to really manage that dependency injection. And so when you start building really large cloud applications, you're going to want to be able to test parts of it, and you're going to want to test those in isolation. And it's great to run full-on integration tests, but if you want some of that rapid feedback, being able to do dependency injection and test with mocks and some of those other things do become very important as part of building an application. And finally, this is another thing that completely changes the way that we write business logic. And that's like another thing that Eric mentioned, is configuration over code. So you can write almost anything you want to in a Lambda function, but you probably shouldn't, right? If you want to go ahead and use that storage first pattern, you want to write directly to SQS or directly to DynamoDB, you're actually putting logic now not in a Lambda function, not in a container. You're putting it in the service that's actually powering the connections between those two things. So there is now another mindset where your business logic is in some way disconnected, because now it's tied directly to the infrastructure configuration. So that really changes the mindset of how you build these things. So build and deployment pipelines, this is another really sort of complex subject. I have in my newsletter, I have an ongoing joke that's basically like, okay, this week, this is this week's attempt at building a CI/CD pipeline for serverless, because they all seem to be different. It's getting better, but for the most part, everybody kind of builds things differently. And that's because you've got packaging steps, which are probably familiar to most things, and maybe compiling dependencies, but then generating artifacts. Your artifacts are no longer just a chunk of code. Oftentimes it's a specific, a version or a specific CloudFormation template that's generated for that specific build in a specific environment, with certain requirements and so forth. So, and with dependencies that are all kind of tied together. So that's another thing that serverless developers need to be thinking about. And again, it's your code, you're writing all this stuff. So this is not an ops job anymore. This is something that the developer now needs to think about. Also, you're running deployments, you're uploading and executing CloudFormation change sets. You're also maybe using, if you're using Terraform or something else, you might be using the API provisioning commands. That's all kind of abstracted away from you, but you still have to think about, how is my infrastructure being modified? What am I modifying, and so forth. And then you go down the path of actually verifying those deployments. So once you actually get the code into the cloud and you make your infrastructure changes, now you're running integration or smoke tests, and you're trying to figure out, whether or not everything is running correctly. And then we could get into this idea of blue-green deployments and rollbacks, and just, this stuff gets very, very complicated very, very quickly. But again, a lot of this responsibility falls on the developer because, again, when you're writing this infrastructure as code and you're writing, maybe using API gateway to do their blue-green deployments, very cool feature built in, but now you're writing all the tests and you're writing all the checks, and that's all part of that one deployment process. The other thing, again, we talked about was monitoring and observability. This is a new paradigm that really falls onto the developer directly, and not just being responsible for sort of sitting there and watching the alerts. That's a different story. But if anybody knows Charity Majors, if you don't know Charity Majors, look her up. She's absolutely amazing. She is a thought leader when it comes to anything that has to do with observability. And one of the things she talks about is test-driven development, which is always great to do. But combine that with your production environment and actual users banging up against the system. And that's what she calls observability-driven development. And the idea behind this is you want to build your system so that, one, you embrace failure. You're always writing in knowing that your system is most likely going to fail at some point. So you're embracing that failure and you're putting in code that is not defensive code to sort of hide the failure, but defensive code that sort of comes in and says, oh, hey, this thing isn't working yet, or this, that we're having a problem with this, or whatever. Like trying to make sure that you're embracing that your application is going to fail. We can't connect to the database. We can't send to this API. Embracing that and putting in code that can sort of address that, but also instrumenting as you go. So oftentimes we see a lot of observability companies that say, oh, all you have to do is just hit a button and we'll install it and we'll do all the instrumentation for you. Now, that may be fine, and that works really well out of the box for a lot of situations, but it's also really helpful to go in and put in instrumentation so that you can really determine, like only you are going to know whether or not your code or how your code is supposed to run, pretty much the person who writes it. So the more you can put in to know and get signals that your code is running correctly, the better. And finally, the idea is close the loop behind that. And what that means is that make sure it's tied into that observability platform. So as soon as that piece of code goes out, you can watch that instrumentation, you can watch that monitoring, and you know whether or not that is now working, because that's the best place or the best time to catch errors is right after a feature goes live, before it's out there for a couple of months, and then a bunch of customers are complaining, and then even worse, you don't even remember how you coded that, because that tends to be a common thing. We forget what we wrote. Just a few days, or in my case, usually a few minutes have passed, and I forget what I even did. So there is an article on this. This is just one article. Charity has a whole bunch of great articles. Charity.dev, I believe, is her blog, but check those out. Really interesting things there. So now if we talk about, again, closing that loop and going to that where, observability tools and alerts, now we've got some new questions. As a developer, who's responsible for code in production now? I mean, unfortunately, it's you, because you're the one who knows that code, right? You're the one who wrote all the interactions with the infrastructure. You're the one who wrote, the deployments. You did all of that. You know what's supposed to happen, and now that is really your responsibility. Now, you may have a team that can help with that, but it is something that you should be responsible for now, which in the old days you really weren't. And I say old days was probably a couple of years ago, but you weren't. And now the other question is, who's responsible for that infrastructure configuration issues, right? So who now has to tweak the concurrency limits on Lambda? Who is the one who says, hey, we need 3 more shards of Kinesis? Who's the one who says, hey, we need to start splitting these Kinesis data streams into multiple S3 buckets, or we have to convert them into Parquet, or we got to do this? These are all questions that are going to start coming up, and who's responsible for those things. So not only the issues themselves, but also the optimization as we go through those. All right, so I promised you a couple of workflow optimization tips. Like I said, I wish there were more, but these are some of the things that I've done in organizations that I've worked for, and these have sort of helped to make it a little bit easier to build serverless applications. This first one really has nothing to do with serverless, but is just a really great practice that I always endorse, and that's the idea of just automatic linting and code formatting. That way, you can catch a lot of errors with this. You also don't have really long lines. You make sure you enforce, especially if you're using TypeScript or some of these other things. Of course, code formatting and linting works. There's services for all those. But I really love this idea of making sure that the code is all clean and that everything is structured the same way, and that pretty or unsave and things like that are always fun. Another important thing, though, is that unit tests are always important. And I know that a lot of people talk about unit tests being less important when you're talking about the cloud. I don't disagree that they're slightly less important in the larger picture, but they are important when you have business logic. And again, using things like hexagonal architectures or ways that you're splitting it up so you can change your dependencies, writing unit tests against the business logic, I think, is always a great idea. And of course, you get immediate feedback if you run that unit test locally. You don't even have to touch the cloud. You don't have to worry about cloud fidelity or any of those other things. But the important thing is, don't write unit tests that test the cloud. Like, just assume that Lambda is going to deliver you the correct event, and just assume that you're gonna get the response back from you're going to get the right response back from DynamoDB and some of these things. We don't have to test those things. We just have to make sure that I should say, we don't have to unit test those things. We just need to make sure that we've written the test to cover the actual business logic and the processing itself. Enabling developer sandboxes to mimic production. This is the greatest thing that you can do to really resolve headaches and also give developers the freedom to really experiment with things. So if you can give each developer their own AWS account or Google Cloud account or IBM Cloud account or whatever you're using, it just makes it so much easier for them to go ahead and spin up infrastructure, play around with it. Serverless infrastructure is so cheap, almost all of it, except for a few minor things like maybe Kinesis streams and things like that, are basically free if you're not using them. So it's always a good idea to do something like that and give the developers the freedom to do that. I used to talk a lot about Git flow in the past was something that a lot of people did. Trunk-based workflows are just so much easier now, just merging into one. Again, this is more not really a serverless recommendation, but just a recommendation for overall workflow. But trunk-based workflows with Git work really, really well because part of that is you're always deploying. Hopefully you have a good CI/CD process in place. And you're always deploying. I like to do the tagging as well because it's a little bit easier to do rollbacks if you need to go back to a particular release build or something like that. But I always find trunk-based workflows to be much more productive and just a cleaner way to do development. Again, we talked about smoke tests and integration tests. Every time you deploy, whether it's to a PR branch or a feature branch, to staging, to your dev environment, or to production, clearly running some smoke tests and integration tests to quickly know whether or not it's kind of checking off all the boxes. And then really consider this idea of blue-green deployments. This is one of those things where it doesn't take a huge effort to get this set up. It's kind of a pain initially, and you got to play around with some different things. But it really is a nice little like safety blanket where when you deploy, if you immediately start seeing failures as it starts to increment traffic, the way it works is it starts shifting traffic for you. There's a really, really good, there's a really good safety blanket there so that if it starts to fail, you can immediately roll it back and you risk downtime. So a couple of other development workflow considerations. These are questions that I get all the time. These are questions that I ask all the time because I'm not sure I know the answer. But things like a monorepo versus multi-repo for serverless applications. Yen Trey has a great article on this. I tend to favor monorepos. I have never regretted a monorepo. I have always regretted a multi-repo. So when you start splitting services up into different repositories, it can get really, really, really hard to manage. Another thing to think about always considering is how are you going to manage your secrets? How are you going to manage cross-account security? So what does your developers have access to? Where are your secrets stored? Can your developers easily access those secrets? What are, just things to consider there and how you do some of the management there. Obviously parameters or SSM and I think it's called parameter store and a couple other things. There's services in AWS that allow you to do this, access them directly either on builds or, there's I think actually speaking of Yen Trey there, the MIDI service has a really cool thing that will go ahead and fetch those secrets for you and cache them automatically. So there's some good ways to sort of deal with that. Another really, really, really complicated question is how do you share code and packages? A lot of people will say, hey, Lambda layers, they're great. They work really, really well. They do work really well for sharing packages, but the management of them is not always as easy. And again, if you get into multi-repos and some of these things, and you're accessing Lambdas across accounts or accessing Lambda layers across accounts and things like that, it gets a little bit more hairy. Private NPM, works, GitHub, installing directly from GitHub, things like that. There's all different ways to do shared code packages, but just something to consider because it's not super easy. Although I will say Architect does a really great job with this. So Architect has some really cool features that they allow you to do that stuff, which is really nice. Another thing to consider is just adding safeguards to our deployments. And that just might be, don't allow your developers obviously to deploy directly to production, or don't let them spin up, different name branches, or, just again, secrets management and some of these other things, just to make sure that we're not deploying when we shouldn't be. These could be also smoke tests, right? Like, maybe you have to run smoke tests against your staging environment. If those all pass, then you'll publish to your production environment, run your smoke tests, or your integration tests again. Another thing that I absolutely love, and again, it's so cheap to do with serverless if it's done right, is feature branch and pull request stack. So every time you create a new feature branch, that should spin up a whole set of infrastructure that you can test against. Same thing with pull requests. So that way, if you have a front end team that might be working on things, they can test against specific pull requests and verify things are working correctly. Another thing this is great for is if you are doing end-to-end tests, you can point those at those different stacks. So that's always a good way to do that as well. And then finally, this idea of partial code changes versus monolithic deployments. Another thing that Eric talked about with Accelerate or SAM Accelerate, which is really, really cool idea, is when can you update just parts of your code versus when do you actually have to redeploy the entire stack? Clearly, if you're doing a mono repo, you want to think about having multiple stacks in that mono repo. So you're not necessarily going to be running a full deployment of your entire application. You might be deploying just one service or one stack or things like that. So just things that you have to think about in your CI/CD process and the tools that you use in order to make that work. So just some other things to think about. All right, let's get on to the really interesting stuff though, because serverless is not broken, but serverless is not necessarily the easiest thing to use because of those things we discussed, because of that huge learning curve that developers have. And one of the things we want to make sure we do, let me go back to this, is we want to continue to evolve on this. And now Serverless Inc. is working on something, but we are not the only ones. Even SAM Accelerate is a really cool step in the right direction. So what I want to do is take you through a couple of these sort of what I consider to be evolutions of serverless, maybe revolutions, we'll see, but really cool things and tools that other companies are building and people are building to try to get us, past these humps and get us past these sort of janky development workflows, and even hopefully better, get us past some of these really difficult learning curves when you start learning individual services across all the different cloud providers. So the first thing I want to talk about is this idea of pre-configured infrastructure platforms. Now, there's a number of these out there. And what's very, very cool about these is that, again, they focus on code only. They focus on deploying a container. They make it very, very simple. But generally, the way these work is they auto scale, but the infrastructure is sort of already there for you. You have certain services that you can use, and you have to expand past those. So AWS App Runner, very, very cool service. This one just launched not too long ago. I don't remember when. But essentially, you just upload either source code or that container, and it will take that, it'll build your application, it'll create load balancers, it'll do all the things it needs to do to run, that type of application. It is, it's scalable. It automatically scales for you, which is also good. But again, it's sort of running, and again, I don't have anything bad to say about these. I think these are great. These work really, really well, for the right type of application. The other one that is really cool is Nimbella. Nimbella just got bought by DigitalOcean, I believe, which is pretty exciting for them. They have a very cool platform, runs on top of Kubernetes, and essentially what they do is you just drop in your code or your package containers. They've got an SDK that you use to interact with their data store, I believe it's called, and essentially that allows you to create stateful applications. And it scales up and down. You don't have to manage the Kubernetes, and essentially you just have to drop in some code. And then another cool one that is recent, I think as well, maybe a year old or so, is IBM Cloud Code Engine. This might be 2 years old at this point, but this is another cool service because again, it's basically managed Kubernetes for you, but you just drop a container in there or your application code. And it can run, and it's got a couple different configurations, but the runtime is completely managed for you. So you have access to a bunch of different services, and you can run this. Those are very, very cool platforms that are definitely, if this is what you're looking to do, these can be very quick onboards or on ramps to get you, to deploy scalable applications without you really having to worry about the infrastructure too much. So the other thing that is really cool, and now these have been around for a while, but edge computing is something that is fascinating to me. I believe Fastly actually was at, they may have been a sponsor last year. I know they were at Serverless Days Nashville last year. But Cloudflare Workers, Fastly, Amazon CloudFront Functions, and there's, I joke here, but there's probably about 2,000 more platforms that are being built out there that are trying to do edge computing. What's really cool about these things is they're super low latency, right? And they're globally distributed. So if you're in the EU or you're in South America or you're in Australia, which I know, if anybody has tried to do a podcast interview with someone from Australia, the latency isn't great. These are the kind of things where, trying to access certain things goes very, very fast. And it can do a lot of really cool things. And some of them have KV capabilities. So they can do key value stores. I believe Cloudflare Workers has this. I'm not sure if Fastly has this yet, but they allow you to actually save and store data within these little compute units, which is pretty cool. They do have limited execution time, right? So we're not running, cron jobs on these, or we're not running large, ETL tasks on these, but we don't need to. That's not really what they're designed for. It doesn't mean that they won't eventually support that in the future, but they really are designed for these lightweight workloads. But there are some really cool workloads that you can do. Things like redirects. One of the things that we had implemented before with Cloudflare Workers was the ability for you, and actually we re-implemented it with CloudFront Functions, is the ability for you to hit a URL or hit a path on a URL and then redirect that to a different page behind the scenes. So you could actually have, a single CDN out front, accessing through these different workers, and then being able to route it to different resources behind the scenes, all serving up on a single domain, which is very cool stuff. Header manipulation is cool stuff as well. You can change headers based off of different things. You could do CORS management. You can do all kinds of things. And then authentication is another really cool use case for that as well. So then there's these Jamstack platforms, which are also really, really cool. So Vercel and Netlify, Cloudflare Pages is new. AWS Amplify is a lot further than just a Jamstack platform, but sort of fit it in there because it is very front end focused. But these do cool things: framework detection, static site generation, deployment management. Netlify and Vercel, automatically, create preview branches and those things for you. And it's very easy for you to do some of that stuff. They all have some form of a serverless function that powers behind them. Obviously, Cloudflare Pages uses Workers, and AWS Amplify has a full-on integrated backend. So you still have to kind of configure some of these things. They give you really cool services to easily configure them. They've got a great admin UI that you can use to configure services as well. But again, it's this really cool sort of thing where it's like, you're not thinking about it. You're just writing a little bit of React code, or you're writing Next.js or whatever, and you're publishing out there. You can put some functions in there, and you can do some really cool things with that. And a lot of them have a lot of extensibility, right? So AWS Amplify, you can basically do whatever you want on the back end for AWS Amplify. Vercel and Netlify are a little bit more limited with their serverless functions, but still really, really cool things to do, and sort of changes the way I think we're thinking about serverless. It's not just the back end, it's also this whole front end process as part of it. So another thing that I want to talk about quickly before we move on sort of to the next step of it is primitives. And one of the things that we see with most of these deployment frameworks is the idea of identifying or having a mapping to primitives. So Architect, for example, when you use their HTTP, I forget what it's called exactly, but they use that HTTP handler or the queues handler or events or WS, they all map to specific AWS services, which is perfectly fine. And it's a great abstraction they use. And I'm not picking on Architect, because Serverless Framework does the same thing, where you take functions, those are directly one-to-one to Lambda. Any events that you put under there, those map directly to the primitives. So whether it's SQS or Event Bridge or any of those things, obviously all of these things, including with Architect, make it a little bit easier to configure those connections. But you still have to identify the primitive that you need. And in most cases, you need the flavor of the primitive. Do you need the SQS FIFO queue? Do you need it to be, do you need it to be a regular queue, and so forth. And then of course the resources section defines, just straight cloud formation. But even if you move to, sort of the newer development, cloud development kits like AWS CDK, the resources are still explicitly defined, right? And you still have to configure those primitives. You still need to know about those. And the same thing with constructs. So even though constructs will make it a lot easier and you use like one line of code to spin up a whole use case or whatever it is, you still are accessing primitives and understanding which primitives and are responsible for the primitives once you spin those up. And then finally, Pulumi, for example, again, this is just picking 4 randomly, but they're all very similar to this, Terraform and so forth. That uses custom resources where you define and configure those primitives based off of the cloud provider you're using. And then you can do something similar to constructs with the component resources so that you can actually group a lot of these into higher level abstractions. All super great services. This is not in any way the wrong way to do it. This is how we've been building, serverless applications for quite some time. This is how we've built a lot of cloud applications, having to, use infrastructure as code in order to do this. But the developer is still, they still need to understand and be responsible for the infrastructure configuration. So it's still a lot of onus that falls back on the developer. So we only have a couple minutes left, so I'm going to go through this quickly. So timing on this was perfect. Just at the end of last month, I believe it was, Sean Wang, you might know him as Swix on Twitter and everywhere else. He published this article, and in it he quoted, "Advancements in 2 fields, programming languages, cloud and cloud infrastructure, will converge into a single paradigm where all resources required by a program will be automatically provisioned and optimized by the environment that runs it." So think about that. This is something that he calls the self-provisioning runtime, which essentially says you shouldn't have to tell the infrastructure what you need. Your code should be enough to tell the infrastructure or tell the system what it needs in order to actually host your application. So there are a bunch of startups that are kind of working on this thing. A couple of them, Lambdragon, cloudcompiler.run. Dark is very cool, and they have their own language, Dark Lang, that allows you to do some cool things. Wasp Lang is another thing. Encore is another one. And these are all really cool things. I would suggest you go check them out if you're interested in what's happening here. But one of the things that we've been working on is this idea of infrastructure from code. So not infrastructure as code, but infrastructure from code. And the principles here were, we only want to write application code, no infrastructure, no YAML, no configuration files. We just want to write our business logic, right? So we want to focus on use cases and outcomes. We don't want to think about primitives. We don't want to think I need 4 Lambda functions and 2 queues and this kind of stuff. Just want to think about use cases. Also, we want to make sure we use familiar patterns, right? So we've defined the business logic with familiar patterns, so we're not reinventing the wheel or writing something new. We want to make sure that the infrastructure automatically deploys and is managed, so it supports that application based off of your application code that you write. We want to provide simple workflows for development, testing, and deployment. And we want to make sure the infrastructure is optimized based on usage. So what we've been building is this thing called Serverless Cloud. I'm going to go through it quickly. I'm not even going to try to give you a demo because it would take too long, and I can never have favor with the demo gods. So essentially what we've done is created these Express-like APIs is one thing you can do. So API.get, you just pull in this little API helper function. Pretty simple. If you've ever used Express, this should look very familiar. We allow you to do scheduled tasks and cron jobs just using the schedule. So schedule.every 60 minutes, do something here. We have a built-in data store we call serverless data. So that allows you to just do simple gets and sets. So if you want to get something by an ID, you can do that. We also added some superpowers to it. So you can do things like collections, and you can query the collections, either get all of them or partials or greater than or less than. So a bunch of cool things you can do there. We just enabled, this should be live today. If not today, it'll be very soon, this idea of change data capture asynchronously. So you can put these handlers to say, every time the data piece of data is created or updated or deleted, I want to be able to do something as a result of that. This is very cool. And you can also put all kinds of filters on this and things. So you can only check for updates to a particular collection, for example, or if the key matches something. So very cool things you can do there. We also have always up-to-date parameters. So no more fetching parameters with SSM or anything like that. Any of your instances that are running that have a parameter, all you got to do is just update it in the dashboard, and it's immediately available and pushed to that securely. These are all secrets, so they're all secure. And then we've built a bunch of these really great workflows, or what we hope are great workflows, where it's super easy. You type in cloud, it walks you through sort of getting started. And then immediately you have these high fidelity developer sandboxes with streaming logs and all kinds of cool capabilities. So now you're actually testing against code in the cloud. So anything you do on your local machine actually gets saved. So you use whatever IDE you want. You run this in the background. We watch your code. We automatically update and modify not only the code, but the supporting infrastructure as well if we need to. So that's automatically done for you. And the upload times are like 5 seconds, and that's going to be even less than that, hopefully in the next day or two. We're launching a whole new syncing system that's awesome. You can import data, right? Every single instance has its own isolated data environment. So you can bring in data just by putting it in like a data.json or users.json. You just run an import command. It sucks that in. You can test different configurations of your app and so forth. You can also do as part of the testing, which I'll mention in a second. And then you have preview environments. So you can just go ahead and type share, and that will create a new isolated instance with the code and the data. This is great for CI/CD as well, for those PRs, for those pull request builds, or those feature branches. You can push it to production with zero friction. So you just type in deploy prod. And of course, this all is compatible with CI/CD as well. But essentially, this will go ahead and create a production environment for you in 9 seconds. This just showed that it creates. So now you go from your development environment to production, and there's a whole bunch of promote commands and some of these other things. And then the testing is really cool. We've extended all of our helpers with an invoke command. So you can invoke those, run just like tests. And then you can either run them in your development environment, or you can run them on dedicated test instances. So this is great for CI/CD, but essentially you can spin these up, run your code, make sure that all your tests pass, and it never touches the actual code or data that you're going to put into production. But it's all but the builds are all deterministic; they're always the same, and so forth. And then we built this really cool dashboard around here, which actually shows you exactly what has been deployed, so your API routes, your schedules, and so forth. You've got some great metrics, logs, parameters, settings, that kind of stuff. So this is now an exclusive launch. There are spots available. Go to serverless.com/cloud. Check it out. Check out some of the other ones I talked about too, because there's really, really cool stuff happening in this space. And the last thing I'll say before I jump off is the fact that I have worked on a lot of projects over the course of my career. I've been doing this for about 22, 23 years or so now. This is the most exciting project I've ever worked on. It is so cool, and it's just absolutely, I hope, an absolute game changer. So check it out, sign up, and give it a whirl, and let us know what you think. So thank you very much for having me. These are some ways to contact me. Again, follow me on Twitter, check out Serverless Cloud, and thank you very much.